I'm very happy to welcome Daniele Marinazzo, who is a neuroscientist and working in the University of Ghent. And Daniele has been a very inspiring figure for us because not only with Lectures Without Borders, we have been following his scientific trajectories, but he also has been in the lectures involved in Nepal, which were organized a few years ago. So today with Daniele, we will go through more neuroscience infused discussions, infused because it will not be just about neuroscience, but also about more approaches to teaching it or communicating it to general public to some extent. So Daniele, would you be able to tell us what was your starting point in the neuroscience?
Yes, so yeah, my starting point in neuroscience was quite serendipitous because, let's say, yeah, my PhD was on the analysis in general of biological systems with the tools of statistical physics. And then, well, during my PhD, well, everyone was supposed to spend a period abroad, and we had agreed with my supervisor that I would have gone in the Netherlands to learn about machine learning. It was the old style machine learning. So yeah, maybe I would not have become rich by now, but it was still something that I needed to learn, and ultimately I didn't. Because now I sort of now because then there was a sort of miscommunication. So the person who was supposed to host me was in sabbatical during the same period, and so I went anyway. And the head of the department there, who was on the other hand working computational neuroscience, agreed to mentor me on this project, which I also liked. And then apart from this project I did during my PhD, then there I met a colleague who was also coming from statistical physics and moving into neuroscience, and I went to visit him for 3 months in Edinburgh. There we started a small project in computational neuroscience, which then needed to be presented to the Society for Neuroscience meeting, where you can only submit one abstract, or at least it was like that at the time. And so basically, I went there just to present this side project we had been worked on. And there I was basically overwhelmed by a huge community of neuroscientist and decided to to pursue my scientific career in neuroscience. And there I met the what would have become my supervisor for my postdoc in Paris, Lyle Graham, with whom I embarked in a completely new thing, like in vivo patch clamp. So single neuron recording and analysis with a very niche technique. So this is how it went, basically.
Mm-hmm. And the further on, as a kind of message to maybe other neuroscientists who may listen to this podcast, who would be very interested to engage further on, right, in the neuroscientific research and journey, what would be your message about how actually to choose right project beyond, of course, the fact that you like some projects? Like there were, maybe you could speak about the human brains projects for those people who don't know it, or the follow-up projects.
Yeah, I mean it's not an easy question. Luckily, let's say the easy part of the answer is that there are really so many projects, so many tools, so many resources that on one hand it's easy to get lost, but on the other hand it's easy to find your happiness in either of these. So we are in a period in which not only the computational capability, but also the way of crosstalk, of interacting online, on following some courses, and so is and even I would say a proper use of large language models if everything else fails. I think that can bring you can embark you in a very nice project. So the important thing is to I mean, science is almost never a lonely road. So to find some colleagues at all levels, so some more senior mentors, but also some colleagues at your same level, or also at the early career stage than you, and start a collective project where everyone can do what they're good at, or what they want to become good at, or what they want to learn.
And specifically, this human brain project, was it something that was inspiring for you to participate? And if yes, could you explain your vision about this project? Because it's very ambitious, and those people who may be listening, they don't know about neuroscience, or know but very
Mhm.
right limited. Could you explain more what's the
Yeah. So with the Human Brain Project, so the Human Brain Project was a flagship project of the European Union, who ran from 2013 to 2023. And well, I remember during the final phases of my postdoc, I was involved in the early talks about it. So this was per se quite instructive, also because then the Human Brain Project changed dramatically its leadership after a couple of years. And so let's say it was a big project, quite pyramidal at the beginning, and then it became more centralized. And I think this is a good thing. And now the project I'm most involved with, rather than the Human Brain Project, is uh, let's say the follow-up of the Human Brain Project, which is called eBrains, which is a European neuroinformatic infrastructure, which has been included in the European strategic roadmap for infrastructure. So it's let's say is part of a set of tools that the EU offers to its citizens, and of course you can access it even outside of the EU. And it is a platform which contains well, everything that has been built during the Human Brain Project, plus new things. So it contains data sets, it contains models, it contains atlases, etc. So this is indeed an example of really a community-centered and horizontal enterprise, which can really benefit neuroscience, and to which you can contribute either as a pure or old school neuroscientist, but also as a programmer, as a modeler, or simply as a user.
Mhm. And it's an attempt to make approachable, right, analysis to neuroscience to everyone, because everyone registered can download, for example, neuroscience data, right, and analyze it.
Yeah, even without downloading it. So there is also a cloud computing service.
Mm-hmm. And as a neuroscientist, for example, when you are searching for next project, next inspiring project, what exactly direction, or like what exactly are you looking for in terms of selection of projects? What
Mhm.
are the main big questions, right, which you would like to answer, or which are out there, but maybe part of those questions you could mention and explain to and now to people? What are the main
Yeah.
questions in general, and maybe the ones which you're interested in?
Yeah. So I mean, I'm probably one of the uh, person who can give the worst answer to this, because I'm really someone interested by small questions rather than big questions. So my scientific curiosity can be completely uh, trapped and engaged by solving a very small niche technical problem, which can keep me busy for uh, a few days in a very intense way. And then once it's solved, then in the best case scenario, I will just put some code on GitHub and that's it, or maybe try to write a paper for a specialized physics audience, etc. So this is indeed one, is definitely a limitation, I would say, but something I should work with if I really want to embark in big questions. But so I'm not a big questions person. I'm sorry.
Yes, but it's related to our next question, because many often times many people, they think that a scientist is someone who is constantly thinking about one big question, right? Like Fermat's theorem, or like, you know, some big things that everyone knows, the Millennium Prize kind of things, while
Yeah,
actually it's oftentimes not the case, right? So
yeah. So one should never really forget that we are all together in a, let's say, in an enterprise from which we can ultimately all benefit. So I'm not saying that science should only be a way of keeping restless minds busy with small projects, because it's not the case. Indeed, that's why I try to make a lot of effort in uh, dissemination of tools of knowledge, etc. So, but indeed, anything that we do can then find its place in one or more projects, which can then lead to big questions.
and for people who are, for example, uh, again, not familiar so much with neuroscience, right? What would be the easiest entry point, maybe some lectures or books that you really like the most in general in neuroscience, which you would maybe recommend, right? Or explain to main concept in neuroscience to basically navigate, right? Because
Yeah. I
big
mean, there are
question.
really top-down and bottom-up approach. So from the bottom up, let's say all the books by Buzaki are really fundamental to understand yeah, the brain and its rhythms from let's say from neurons to what we then record, and then from someone like me coming from physics, books on I mean, for me, for example, several books by Steve Strogatz, both those on network science and those on synchronization and chaos or dynamical systems, were also uh, fundamental. Now, it's already quite a few decades ago, but still, I think they are good. Of course, great classics like Candle, big neuroscience book. It really contains everything we need. Or the book by Diane and Abbott on computational neuroscience. Books by Thierry Sejnowski on machine learning connected to neural systems, and so on. And then there are a lot of let's say grassroots initiatives, such as the Neuromatch Academy, which happens every year. So one can enroll as a student, but can enroll also um, uh, as a mentor, or as uh, let's say, I don't remember how it's called exactly, the figure, but someone who guides the students through practical project, let's say. So like some practical assistance or something like that.
Mm-hmm. Yeah, that's really something that we were looking for, because quite often the lectures that people are participating in for example, in lectures at Boros or in any, right, like broader audience way where people are just searching for field where they will engage into. For them, it's not enough, so they need to continue their journey. So maybe that this academy that you, for example, mentioned, right, can be a good place to, in general, if you want to go further. But for your personal journey of bringing or like making lectures, right, to people who are not maybe necessarily from the neuroscience background or neuroscience students, what are the main concepts that people need to be aware of, right? Because after, when they will be more selecting their own questions and pathways in their research endeavor, that will be very specialized. But before that, what are very important fundamentals from your point of view to know?
So mostly the trade-off between a holistic view, which is nowadays the more, let's say, the more used view, if you want, because a lot of concepts such as, I don't know, uh, manifolds, networks in the wide science sense, etc., they speak to considering many units that do things together in a reduced dimensionality space, etc. But then without forgetting the fundamentals, the level of things that we want to do. So basically not to get lost between different levels. So there is the level of things that we cannot observe but are our target properties. So for example, the dynamics of neural populations, etc. Then we have the level of observables, so what we can record, and all the confounders or the statistical dependencies that we compute, all the statistical properties, both local and global. And then there is the level of inference, so how we try to make sense of what we record and what we compute in order to understand something about the target properties. So it's good to acknowledge that these three levels exist, and also to acknowledge the danger of leakage between these levels. So sometimes we try to attribute to the target properties, the things of the biological system that we cannot observe, some properties which are properties of the mathematical tools that we use to study them. And I think this is a fallacy, and we should be aware of this. So this from the fundamental epistemological theoretical part, and then from the practical part, of course, take good care of the implementation, of the dissemination. So I have a code which is in a good shape to be reproduced, to be used by others, and to be interoperable, etc., both for code and for data.
Mm-hmm. Mm-hmm. So maybe more than on the side of continuing this approaches to explaining or teaching, if you want, neuroscience, rather than just doing fundamental research. What then would be your main kind of things to work on when you want, for example, to teach neuroscience, right, to someone who is not familiar? What would be the approaches that you would explain your concepts? I mean, I know that from your experience in teaching in Nepal, it was nice, but what were the concepts that you explained? Were they related to your research? Could you share?
Yeah. So yeah, just to give a bit of context, yeah, I was visiting Nepal for another conference, and then through the Lecturers Without Borders network, I was put in contact with some colleagues from the Nepal College of Information Technology who were, let's say, very kind and welcoming and enthusiastic for me. It was the first day there, and also after a quite long trip, after which I wasn't even feeling 100% physically okay, but they were so welcoming, and so they brought me to visit their college, etc. And for me, it was a very nice experience to talk about my research in a context that was new for me, and for what I thought, it was not so much different from the thing I usually teach or I usually present to my colleagues when I visit other universities. So in this case was uh, multivariate decomposition of information in systems with many variables. So yeah, it was basically extensions of entropy and mutual information to multivariate systems, and what can we do with this?
Mm-hmm. But there was, since it was actually a lecture organized in Nepal, right, and not in Belgium and in any other European countries, were there some things with you have noticed from maybe questions or approaches? Because we're always interested in this kind of cross-border experiences in teaching, right? Like what
Yeah.
was maybe some things that you noticed were the differences, or maybe they were known, because that's a
Yeah, actually, no, there were no, I mean, uh, not many difference. So I, well, I also didn't expect many differences. So of course the environment was quite different, was completely new for me, etc. But then once you enter a building, I mean, most universities have a, let's say, a general resemblance, I would say. And then in the audience, yeah, there were people who engaged with a lot of questions, people who were more well, shy or reflective, or people who really appreciated my lecture. Some people, which I can imagine, they didn't find it particularly compelling, as it always happens. So no, in this case, I didn't find any difference, I would say.
Mhm. But for people who are not yet, who have not yet done such right experiences of teaching, for example, neuroscience specifically, or generally like mathematics or analysis of data in doing the lecture in other country, uh, they do you think that in general these cross-border experiences of teaching someone is something that people do value in general, or it's something that you think is still experimental and needs to be a bit further more adapted for in terms of
I
teaching?
mean, I don't know how we could say, well, these things need to be adapted in a general way. I think it's something that in some cases can work completely smoothly and be completely enriching. In other cases, a bit less so, etc. But so if I would have to give an advice, I wouldn't know where to start. I would just say keep doing this because it's great to give this opportunity, and then I think each case is is particular per se. So, for example, in my case, I didn't have the chance of teaching either something which is outside um, um, of my usual research, or to a group of people that are not the usual people I teach to. I mean, within the Lecturer Without Borders. I did so with other schemes, such as the Skype Scientist or other mentorship programs, even within my own university. So every time it was enriching in a way. So yeah, if I would have, for example, have the chance to go in Nepal and teach to a school of I don't know 10th grade children, it would have been of course more challenging, and it would have need to prepare quite more, etc. But so for me, it would have been definitely a great experience, I think. I don't know for the for the pupils whether they'll say, okay, why is this guy is coming to us, etc. But usually, one of the good things about science and about mankind in general is curiosity. So whenever something new can trigger some curiosity, then I would say that we don't need anything else.
Yeah, I agree with that. Yes. And this is something that drives also a lot of research and activities. And maybe the last but not the least important question is about the perspectives, for you in your personal research, because I know that you work also on not just neuroscience and networks, but also neuroscience and hypergraphs. That is something which is a bit more, going further on concept extension from networks theory. What are the main research-wise projects, maybe very specific ones that you personally work on and people maybe just want to know, who want to know more what researchers are working on in neuroscience? What are those? And could you
Yeah,
tell?
so let's say the new things I'm working on. So on one hand is indeed the still in the framework of multivariate information decomposition, which I think is something which is very versatile and very suitable to address many types of data and to answer many questions. So one application, for example, is now to psychometrics, which is something that went a bit outside of my field of expertise, but luckily I am in a department where I have some colleagues who let's say, embarked with me in this journey of co-supervising students and also trying to find a good way to uh, disseminate this concept. So yeah, the idea is that in many behavioral settings, mental disorders, or even not outside the clinic, even just in the analysis of behavioral data, etc. There are some observables that co-vary across different subjects, and by looking at these covariance, we can learn about what are the maybe most relevant um, symptoms of a disease or some relevant behavioral quantities in a certain group of people, etc. And so, in this sense, the extension to interaction beyond the pairwise, so looking at information shared in groups of 3, 4, 5 variables, etc., is a complementary way to show these things as a network, not necessarily a network where you have pathways and nodes, but a network in the wider sense of collective behavior.
Mhm. Yeah, we will put all the links to the papers and books that you mentioned, maybe also specifically on that, because if people who are interested in finding their research questions would be interested in that, would be specifically useful for them. And also links to your department in Ghent University, where you have your students. So with this, I would like to thank you for our for your time, for our discussions that we will show to broader audience. I hope that it will be helpful for some people to find their own path in neuroscience or beyond. And I specifically like that you work in very, very interdisciplinary groups, research groups. That is very inspiring because you work with doctors, right? And people who are in departments or in hospitals, right? That's really something that sparks, I think, a lot of new, interesting research questions. Can.
Yeah, I mean, certainly for me is an enriching is a way to learn a lot and to be exposed to a big number of simulating people. Yeah.
Mm. Thank you so much. Thank you, Daniele. Thank you.
Thanks to you, Luba, and thanks for everything you're doing in this field. And talk soon.